Welcome to Homework Lib.
Here for the compound shown below, we are asked to identify the signals for proton NMR spectrum, and in this case for carbon NMR spectrum, and indicate the different protons that we're going to have. So for proton NMR spectrum, we're going to have the signal. First signal would be A and A. This is going to be a symmetric molecule. The pair of hydrogens on both over here are all going to appear on the same signal, since this is going to be completely symmetric. So for the first compound, we're going to get two signals. For the proton NMR spectrum of this compound, we're going to have the first signal being A and A. Next up, we're going to have both of these are going to be equivalent, B and B. And finally, C and C. So we're going to get three signals over here. Now, for the carbon NMR spectrum, what is going to occur is that this carbon corresponds to A and A. Next up, the two carbon atoms over here would be two different signals at B. And lastly, all of these carbon atoms are going to have the same shift on the carbon NMR spectrum, C and C. Let me put this in green so that it shows up better. Since for some reason here the red doesn't show properly. So over here we're going to have three signals. Now for the next compound we're going to get. Oh, sorry, I just realized over here a mistake that I made on this compound. This one would appear at a different value since the environment is not going to be completely identical. This would be signal D, accounting for four signals. And now continuing with the carbon NMR spectrum, we're going to have signal A, signal B over here, signal C and C, signal D and D. Next up, E and E, F and G. So we're going to have 1, 2, 3, 4, 5, 6, 7 signals. For the second compound. Although in both of the cases, for example, in the NMR spectrum, signal A and D is going to be super close together. Same thing here with signals A and G and B and F. They're going to be very close together. In the S spectrum. Now we're going to give the expected splitting patterns for the labeled protons in the following molecule, and over here remember that we're going to follow the n+1 rule, where n is going to be the number of neighbors or neighboring protons that we're going to have. So in this case, for the first compound over here, we're going to have 0 neighbors, so this is going to be a singlet. Next up, on this position, we're going to have 3 neighbors and 1 neighbor. So for that reason, we're going to get a quintet. Now, for this signal over here, we're going to have only 1 neighbor corresponding to this position. Thus, this is going to be a doublet. Same thing goes for this signal over here. This is going to be a doublet since we are only going to have 1 proton as neighboring. And the final one over here, we're going to have 3 neighbors coming from this position, 1 neighbor coming over here, and 2 neighbors coming over here. So 3, 4, 5, 6, which corresponds to a septet. Since we have 6 neighboring protons to that signal. And with that, it would be all. Thank you very much and have a good one.